Let's talk about Kirchoffs First Law. There are two laws of Kirchoffs in electrical network which plays important role in solving problems which are complex in electrical network. Kirchoffs First Law says that the algebraic sum of currents at a junction is zero. Sigma I equal to 0 is mathematical form of Kirchoffs First Law. Let us try to understand what it says. Here the two words are important. One is junction and the other is algebraic sum. So what is meaning of algebraic sum? This is the diagram. It is a part of an electric circuit, and this is a point where many currents are coming and leaving. So junction is a point where three or more components of electric circuit meet. So this is junction. We have five currents here or five components here. So current I1 is coming towards the junction, I2 coming into the junction, I3 leaving the junction, I4 leaving the junction, and I5 coming towards the junction. So by the definition, the algebraic sum means we consider the currents coming towards the junction as positive and the currents leaving away as negative. And if you add all of them, turns out to be zero. And the reason why it is zero is current will not stop at a point, or the charge will not stop at a point. So this law is based on law of conservation of charge, that the charge which flows at a junction has to leave the junction because we do not expect charge to stay at a junction. So based on that, we define Kirchoffs First Law. We can also define Kirchoffs First Law in another way, that the sum of the currents flowing towards the junction is equal to sum of the currents flowing away from the junction. Other name of Kirchoff's law is Kirchoff's junction law, also current law. So we call Kirchoff's first law as in short form KCL, meaning Kirchoff's current law. If I apply Kirchoff's current law to this particular diagram, let's see what we get. So I1 is coming towards, so this is plus I1, and I2 towards, so plus I2, and I3 leaving away, so minus I3, I4 leaving away, minus I4, and finally I4 coming towards, so plus I5 is equal to 0. This is what is called algebraic sum. In another way, it can be written as I1 plus I2 plus I5 is equal to I3 plus I4, which means these are the currents coming towards the junction is equal to the currents leaving away from the junction. This is Kirchoff's first law. Let's discuss about Kirchoff's second law. Kirchoff's second law says that the algebraic sum of potential drops in a closed loop is 0. First law was algebraic sum of currents in a loop is 0. Second law is algebraic sum of potential drops in a closed loop is 0. Let's try and understand what is Kirchoff's second law with an example. In this example, I have considered a circuit with 3 resistors and a cell, and there is a switch. When you close the switch, conventional current starts from the battery, positive terminal, passes throughout the circuit and reaches the negative terminal, and it moves in the circuit. So the circuit is complete. Now let us apply Kirchoff's second law to this loop, because it talks about a loop. Loop is a closed electric circuit. The other name of Kirchoff's second law is Kirchoff's voltage law, and in short we call it as KVL. So how to apply Kirchoff's voltage law? We add all the potential drops in a closed loop and equate it to 0. Let's see how to do that. This is a loop A, B, C, D, A. Let's apply Kirchoff's voltage law to the loop A, B, C, D, A. Starting from A to B in this branch, there are 3 resistors and potential drop is 3 times. We know from Ohm's law, the potential drop is the product of current and resistance. So when you move from A to B, you come across 3 resistors. The potential drop across the resistor R1 is I into R1. The potential drop across the resistor R2 is I into R2 and I into R3 across the resistor R3. So the equation will be, since it is a drop, we would write minus I into R1 across R1 and minus I into R2 across R2 and minus I into R3 across R3. So moved from A to B, 3 times the potential drops. IR1, IR2 and IR3. Suppose you move from B to A, the potential is gained. So you would write plus IR3 plus IR2 and plus IR1. While solving problems, we will get more clarification about this one. Let's continue this. So minus IR1, minus IR2 and minus IR3. And when you come across this branch BC, it is simply a wire or a conductor with 0 resistance. So then, and hence there is no drop of potential here. And when you move from C to D, you come across this cell. See, you are moving from C to D, and when you come across this cell, you are moving from negative to positive, lower potential to higher potential. So it is potential gain. So you write plus V. And move from D to A, there is no potential drop. So you have completed the loop. So sum of the potential drops in a loop is equal to 0. Let's solve this equation. You get V is equal to I into R1 plus R2 plus R3, and the current I is equal to V upon R1 plus R2 plus R3. So using Kirchoffs potential law or Kirchoffs voltage law, you would be able to find out the current in the loop.